Alrighty, good people. Welcome to video number 2 of slope fields. I went ahead and did the y-axis point slope field section. Did you try it? Did you get something similar? Again, remember, a slope field is just giving us a little segment of a tangent line on the original graph, even though we can't see the original graph. We don't have the formula for the original graph. But we can find the slope of the tangent line of the original graph at any given point because we have a differential equation, which is just an equation that involves a derivative. Okay, but in this, oh, so I'm sorry. So this is the complete 10-point slope field for example number 2. If you have questions on how we did this, when you come back to class, we can talk about it. So the second type of slope field situation you'll encounter is you will be asked to sketch a solution curve through an indicated point on a slope field. And all that means is, remember, the slope field is there to show us what the tangent lines are looking like. But if we draw a graph through, not, I shouldn't say through, but if we graph a curve using those tangent lines, we're actually going to get the solution curve, the original function that we were talking about. And so, things to remember, when we draw a curve, it must be a function, so it has to pass a vertical line test. You can't draw a graph that goes like this, right? That's not a function. Second, the solution curve has to be continuous. There are no vertical asymptotes here. And if there are, then the solution curve is going to stop, right? Don't go through it. You have to remember that the solution curve has to pass through the indicated point, and make sure that you bold the point that you're talking about to make it obvious that that's the indicated point. And then finally, make sure to extend the curve all the way to the end of the slope field. Don't just stop and use arrows and say, oh, it's going to go in that direction. Take it all the way to the edge of the grid. And so we're about to do that with example 4. A portion of a slope field of the differential equation dy dx equals cosine of y is given below. Sketch the solution curves, so there are two curves, through the points 2, 3, and 0, 0. So we're going to do 1 at 0, 0. We're going to do 1 at 2, comma 3. So let's start with the maybe the more obvious one, which is a 0, 0. So I'm going to plot a point at 0, 0. And remember, the tip is to make that an obvious point. So make it bold. Remember, the slope field is made up of tangent lines. And so the tangent lines are your direction. So follow the directions. I think of it as whenever there's construction on the road and you know how they put those cones and you're always trying to, you should be staying in between the cones. That's really what we're doing here. And so as I go to the right, I'm going to follow the direction of these little lines. So these little lines are telling me, hey, go in this direction, go in this direction. Oh, look, it's kind of flattening out. Oh, look, there's a horizontal asymptote. And so I should get close to it, but not touch it and take it all the way to the end. And that's it. Now on the other side, as I go to the left, starting from that point, the little lines are guiding me. It doesn't have to be perfect, but they're guiding me and they're telling me to go in this direction. And as I go in this direction, I encounter another horizontal asymptote. I know that because all these slopes are 0, and so it should flatten out and go this way. You just created the solution curve for that differential equation that goes through 0, 0. And that's all you have to do. Notice it's not perfect, right? However, this is the general shape of the solution curve. Here's what we don't want. We don't want you to start here and go, oh, I'm going this way and then that way. You're cutting across those cones, right? Like you're going against the grain. Well, no, don't do that. Follow the directions that the slope segments are telling you to follow. Okay, second point, 2, 3. I see 2 right here. I don't know where 3 is, but I know this is 2, so 3 is somewhere here maybe. I don't know. We'll say it is. Okay, as I go to the right, I'm following the lines. Follow the lines. Follow the direction of the lines. Follow the direction of the lines, and then remember this was a horizontal asymptote, so it's going to flatten out. And then on the other side, follow, follow, follow. Don't go against them until you get to here. And again, don't stop there. Take it all the way to the edge of the grid. And that'll be something like that. The solution curve to the differential equation dy dx equals cosine y that goes through the point 2, 3 is this orange curve. You're using these little lines to guide your graph. This is the original graph. The derivative of this original graph is cosine of y. That's what was given to us. So what we're really doing is we're solving this derivative, which by the way is in terms of y, not in terms of x. So we're solving this derivative, we're finding the original function, and we're doing it graphically using slope fields. So slope fields allow us to create an estimate of the graphical solution of a differential equation. All right, let's try one more. A portion of the slope field of the differential equation dy dx is equal to x over y is given below. Sketch the solution curves that go through these 2 points. 2 points again. Okay, so let's start with 0, 2. 0, 2 would be right here. Now remember, make it nice and bold. And now we're going to follow the line. So as I go this way, I'm going to stay between the lines. Uh-oh. Now the lines are angling. Uh-oh. Now they're getting positive and they're going in that direction. And as I go to the other side, I follow, try to stay in between, try to let the lines guide me, and it goes something like that. Congratulations, you just found the solution curve to that differential equation that goes through 0, 2. That's it. That's all you have to do. We'll do this last one. 1, 2, 3, and then down to -2, which is somewhere here. Maybe, yeah, let's make it a little bit bigger. Okay, so this one says go in this direction, go in this direction, go in this direction. And I got to the edge of the grid. On the other side, I'm following it. I'm following it. Uh-oh. Now it's doing this business. And I'm following the direction of the field, and it goes that way. So in blue, I have the solution curve to that differential equation, and I found it by using the slope field, which represents tiny little tangent lines to the curve. That's all you're going to be asked to do. Sketch a solution curve based on a slope field, or create a slope field using the differential equation that's given. And that, my good friends, is sections 7.3 and 7.4.